Hi there everyone, and I just want to welcome you right here for this mathematics lesson only on iTTV. My name is Mr. Joel, your tutor. Alright, so in this lesson we're going to begin with a new chapter, and this is a very interesting chapter. The title of this chapter is Transformations. Alright, so now let's take a look at what we're going to learn in this lesson. Transformations tree. In this lesson, we are going to start by revising the basic concepts of transformations. The four types of transformations are, firstly, translation, secondly, reflection, thirdly, rotation, and fourthly, enlargement. Alright, so you guys are pretty familiar with transformations, right? Because you have learned the first and the second editions of transformations earlier, alright, in the last year or so, right? So what we're going to learn in this lesson is basically an extension of transformations, but make sure you guys understand that there are only four types of transformations as how you see them right here. Alright, so this, guys, is a brief outline of what we're going to learn in this chapter. Taking a look at that, you can see that you can divide it to two types of transformations, alright, and basically where does each transformation fall into, and what you'll be looking at later on in this chapter, which is combined transformations. Alright, so before we get into all that, now let us take a look at what does transformation mean. The word transformation means to change. Alright guys, so remember that transformation means transforming something to become something else, alright? So when the word transformation or transforming is mentioned to you, what always comes to your mind? Let's take a look, right? I'm sure all of you will think of these famous characters that you see, right? The Transformers. So here we have one of them that transforms into a jet, right? One of the bad guys. But that is not the end of the story, because every story ends with a good note. And to fight the bad guys are the good guys. So this is another one of those characters that changes into a super cool car, alright, and basically transforming into another shape. Alright, so what does transformation got to do in mathematics? Alright, it's not this kind of, alright, super high-techy kind of stuff. Alright, but what we're going to learn in this chapter is basically the transformation of mathematical objects in the Cartesian plane or in the x or the y-axis. But you can relate to this in some way, alright? So now let's take a look at some more important properties in transformations. In geometry, a transformation changes the position of a shape on a coordinate plane. Basically, it is the movement of an object from one place to another on a plane. Alright, so what we are dealing with right now is geometry. And when geometry is involved, shapes and spaces are involved. Now, let's take a look at the four transformations in mathematics again. Alright, so firstly, translation. And I want you to take a look at this. Alright, so what we have here and what you see right here is actually a translation. Notice that the object is actually sliding, right? And you can see it sliding from one position to another. Translation takes place when all points on a shape moves in the same direction from one place to another. When you watch the shape move, it appears to be sliding. Alright, so the first transformation is called translation, and I'm sure all of you remember it, right? It is just the movement, or like the object is just sliding from one place to another. Okay, so it moves in a certain condition. We'll take a look at that later on. Alright, now let's move on to the next one, reflection. Take a look at this, alright? So what do you see here is the reflection of that object. Okay, and when it is reflected, it is like a mirror image. So it is reflected across that line that you see right there. Now, explanation about this transformation. Reflection takes place when a shape is flipped across a line and faces the opposite direction, just like the image reflected in a mirror. So when you guys take a look right at yourself right in the morning, you can see a reflection of your image. Alright, so that is the same kind of things, alright? But in, alright, the Cartesian plane, an object is always flipped across a line. We'll also take a look at this later on, alright? Now, let's go on to the next type, or the third type, which is rotation. Now, rotation is a very important transformation. Take a look at what briefly is a rotation, alright? Take a look at this illustration, and you can see that the object is rotated around a fixed point. Alright, so rotation can happen in two directions, clockwise and anti-clockwise as well. And there is a certain angle, 90 degrees, 180 degrees, and so on. A rotation occurs when an object is moved about a fixed point through a given angle in a clockwise or anti-clockwise direction. It almost looks like a clock hand turning around the face of a clock. Okay, so just remember, when rotation is involved, just imagine, alright, the clock hand moving, alright, and from a fixed point, which is the center of the clock. And the final transformation is an enlargement. Alright, take a look at what we have right here. Alright, so you can see that the object is enlarged, alright, from a fixed point to become a larger image. Enlargement in mathematics is resizing an object so that it becomes bigger or smaller, but it still looks similar. Alright, so all of these transformations have been done, alright, in the previous edition, so there is nothing new. We're just going to combine them later on, alright? So now let's take a look at the first two transformations which are in this lesson, okay? So we're going to take a look at firstly the translation again. In geometry, translation simply means moving without rotating, resizing, or anything else. Just moving. Every point of the shape must move the same distance in the same direction. Example, translate the shapes by the corresponding vector to form a letter. Which letter is it? Alright, so now we're going to take a look just at translation first, because as we go on later, we need to really understand, alright, what is translation, reflection, rotation, enlargement, and so on, alright? So now let's focus on translation. So what I'm going to show you right here from this example is, take a look at this diagram. So what we have here is actually three shapes, right, or three objects. You can see both of them, alright, in red and the other in blue. So beside those, alright, objects are actually vectors. And what are vectors? Vectors are actually numbers written in brackets. And this is the way to represent a translation, right? The number on top represents the movement on the x-axis, and the number on the bottom represents the movement on the y-axis. Now, I'm going to move all these three same time, and what alphabet will they form? Let's take a look. The letter F is obtained. Okay, I'm going to show you shortly why. Let's take a look at the three translations. Translation of 0, -3 means it moves downwards by 3 units, because -3 is on the y. -4, -2 means it moves to the left by 4 units for -4, and -2 means moves downwards by 2 units. And if the translation is 4-2, it means it moves to the right by 4 units for the x and moves upwards by 2 units on the y. So this is the letter that you get, and you will get an F. Okay, so as you can see here, it is actually the movement of the three objects at the same time, because every object undergoes a certain translation. So when you move it all at the same time, it will come to a position where the letter F is obtained. Okay, so it is pretty much the same concept, right? But the translation can be different kinds of translations depending on the movement on X and Y. So remember the sliding effect. Okay, all right, now let's take a look at the next example, and we will do this together. All right, so take a look at this diagram first. All right, we have the object A. Now, the diagram shows object A on a Cartesian plane. Transformation X is a translation of -4, -3. The image of object A under transformation X is... Alright, now let us draw the image of this object A under the transformation X, which happens to be a translation of -4, -3. Now let's go over to the board. Alright, so from the question, it tells us, alright, everything in detail. In this diagram, we have the object A. Okay, so it is situated in, alright, the Cartesian plane. And before we actually draw the image, let us go through the translation again. Alright, so the translation that is involved is a translation of -4, -3. Okay, so this is the transformation X. So X represents this translation, alright, of -4, -3. Now, how are we actually going to draw this, alright, image of this object? So guys, remember, translation is actually made up of two parts. Okay, what are the parts? When you see a bracket which is in the vector form, the top number represents the movement on the X, the bottom represents the movement on the Y. It means that this object has to go 4 places to the left because it is negative on the x-axis, and after that 3 units down on the y-axis because it is -3. So positive or negative just shows you whether it goes right or left for the x or up or down on the y. So you must always do x first followed by y. Alright, so let me just demonstrate to you how are we going to perform this translation on this object A. Okay, so as mentioned earlier, we need to do the x first. -4 means 4 units to the left. Okay, so if we have the object A, which is right here, what you have to do is to pick one of the corners or one of the vertices. Okay, so if I pick this corner or this vertex, I move it by 4 places to the left. Alright, so let's count 4. 1, 2, 3, 4. Alright, so I just mark it right here. Okay, and then I have to move it 3 units down. So from here, I move it 1, 2, 3. So this is the position of this point. See, it is moving along this path. 4 to the left, 3 down. Okay, what about this point? Same thing, right? Move 4 units left. So 1, 2, 3, 4. 3 units down, 1, 2, 3. So there it goes. So I don't have to actually move all points because in a translation, the object doesn't change shape, it doesn't change size, it moves, alright? And the orientation will be the same, which means it still points to the same place. Okay, so if I were to just connect them, this is what it will look like. Okay, the other point will be here. So let me just connect them all, and you can see that the object or the triangle A has actually moved already. Okay, so this is how it moves, and this is the image of this object. Okay, and I always label it as A prime. Okay guys, so remember in translation you always move, alright, X first and then Y, not Y first and then X. So we say that it is like sliding and sliding to this image here. Alright guys, let's take a look at the next example, still on translations. Take a look at this diagram. I want you to now try this out. Alright, so you can see that there are actually two, alright, triangles right here, B and B prime. The diagram shows object B on a Cartesian plane. This object undergoes a translation of x, y to B prime. Find the values of x and of y. Alright guys, I want you to try this out. It is very simple. I want you to now take a look at the diagram again and find out what are the values of x and y. Okay, so now we are just getting used again to the concept of translation. So what is it now? Take a look now. We have B to B prime. And can you see that B and B prime, the shape is the same, its orientation is the same, it doesn't move anywhere, it's not bigger or smaller, it is just appearing to have a sliding effect. So it moves and slides until this place. Alright, so this transformation that brings B to B prime is called a translation. But this translation now is incomplete because they told us that it is a translation of x, y. Okay, and what is x? We know it has to be done first, followed by y. So all we have to do, guys, is to count the grids. Okay, and as I told you earlier on, take a look. This is the object, this is the image. So the object always moves to the image, alright? So in order to find out, don't pick all the 3 points at once. You can actually just pick one of those, okay? And I will pick the top one. Okay, so you can pick any point that you want. Alright, so this top point will actually be translated to this top point because they are the corresponding points on the same object, but just in different positions right now. If you choose this point, it will be here. And if you choose this point, it will go to here. So now, going back to the first point, how does this point end up to become this point? Remember, translation, you have to move X first. So you have to move horizontally first. So move to a position where it appears on top right of this. Okay, so let us count how many are there. All right, so if I were to count, let's start from here. All right, so it will be 1, 2, 3, 4, 5, 6, right, until it is directly. So it has moved 6 units to the right. And how many units down? 1, 2, 3, 4. All right, so can you see that the movement is 6 to the right, 4 downwards? So we know that the translation now is actually 6, because it is 6 positive, right? And negative 4, because it is 4 downwards. So that makes our value of X as 6 and our value of Y as negative 4. So in other words, we are just completing the translation. Alright guys, so that is basically a recap on translation. So remember that it is one of the easiest transformations actually. Now let's go on to the next one for this lesson, which is reflection. Now, the idea of reflection. Reflections occur everywhere. In a mirror, glass, and even in a lake. In a lake, let's look at the following picture. Now, take a look at this beautiful picture right here. So you can see a nice, majestic mountain, right? But I want you to notice that we have a crystal clear lake there, right? And the water surface is actually so clear until it can reflect the whole mountain. And can you see that actually there is a reflection of the mountain on the surface of the water? So this is called the reflecting effect. Alright, so this is how reflecting occurs, alright, in our everyday lives. You can take a look at a mirror, for example, right? Or even in a pond and so on. Now, this is something very important. If we were to just focus on this diagram again, take a look right now. Notice that when we reflect the mountain, its distance between the top of the mountain and the top of the image in the reflection is exactly the same from the middle line or the horizontal line, right? And you can take another point, for example, somewhere lower, take a look at the arrow, and its distance will always be same from the line of reflection. So every point is of the same direction from the reflection line. The reflected image has exactly the same size as the original object. The mirror line is also known as the line of symmetry. Alright guys, take a look at this. These are some important terms that you guys must get used to. Alright, so when we have an object, when it is reflected, that line, alright, that causes the reflection to happen is called a mirror line. So this is an example of a reflection that can happen. Mirror line. So it doesn't matter in which direction the line of symmetry goes, the reflected image is always of the same size as the object, it just faces the other way and always equidistant from the reflection line. Alright, take a look at both of these diagrams right now. No matter how you arrange it, alright, how you arrange the mirror line, what you will get is always the same distance between object and image, alright, but notice that the object and image will always be facing, alright, each other. Means they are actually in opposite directions. So in a reflection, remember, the image doesn't change size. It just changes the orientation. Okay, but the shape is exactly the same. So remember, they're reflecting across a mirror line. Alright, now let's take a look at some illustrations. Alright, take a look at this example. What letter would you get if you reflect each shape in its corresponding line of symmetry? Okay, now I want you to do the same as how we did for the translation earlier on. We have 3 objects right here, and those 3 lines right there are actually the mirror line. Now I want you to actually visualize. Okay, how are you actually going to reflect these 3 objects across, or just flip it across the line? And what alphabet will you get? Alright, so this is what we'll get. Take a look closely and you will figure it out easily. When we reflect every object, we will obtain the letter E. Am I right? Take a look carefully. Alright, so everything is pretty clear. This is what the reflection effect does. So one thing to remember is this. The distance of object and line of symmetry equals to distance of image and line of symmetry. Alright, it is called equidistant in other words. So bear in mind that you need to flip the object to its opposite. Alright, so just remember, okay, you're actually flipping it. Okay, so imagine flipping across a certain line. That is what is called a reflection. Alright, next example also similar. Take a look. What letter would you get if you reflect its shape in its corresponding reflection line? Alright, I want you to do this right now. Same thing. Okay, take a look right now. We have two objects only, and the two lines are there, one for each object. I want you to flip, alright, the blue object and the red object right now. And what alphabet will you get? Alright, taking a look closely again, what do you think? Alright, the alphabet will be obtained. Take a look right now at the effect of reflection. So when you reflect it, this is what you get. Alright, the red reflected upwards, alright, the blue reflected sideways. So you will get the alphabet U. Alright, so remember, this is just a way to make you all get the idea of reflection fast. So although the line of symmetry is neither horizontal nor vertical, the concept of reflection is still the same. So as long as you have a straight line, you can reflect any object anywhere at any time. Okay, and you will get the image. But remember the properties of reflection. Alright, now let's take a look at one more example. Alright, the diagram shows object A drawn on the Cartesian plane. Show the image of A after a reflection on the y-axis and a reflection on the x-axis. Okay, now, two popular lines that are used as mirror lines or axis of reflection are actually the x and the y-axis when you draw it on the graph. Now, let me just show you how we reflect a certain object across the x-axis or across the y-axis. Alright guys, let's take a look at this object. Alright, so we have an object A here. Now we're going to reflect it, alright? So remember, it is the second kind of transformation. Firstly, across the x, okay? So now, x-axis, this whole line is actually a mirror line. Okay, so remember that it is an axis of reflection. And when we actually flip it across, so just imagine it flipping right here. Okay, so what will you get? What is the image? So remember, mirror image. Okay, so remember, it's exactly the same when we flip it across the x. Take this point for example. When you flip it across, it has to be same distance from the mirror line, which means it is 1 unit from the axis. The image has to be 1 unit as well. So this will be here. What about this? Same thing, okay, because this is the line, its distance is 2 units. So the image must also be 2 units away from the axis. And what about this? Count properly. 1, 2, 3. 1, 2, 3. Okay, so these are the 3 points when you reflect it. And what will you get? Let's join them together. Okay, and this is what you will get. Okay, so remember to do it nicely, neatly. Alright, imagine, alright, drawing it carefully. Okay, so can you see that a reflection has already occurred? It is actually the total opposite or facing each other. Okay, so this is the result when you flip it across the x-axis. So I just label it as A1 prime. Okay, now what happens when we flip it across the y-axis? So the y-axis is another straight line. So imagine it being the mirror. Okay, and you're going to flip it across. So make sure the distance is the same. Okay, so if we take this point, how many units is it from the y-axis? 1, 2, 3. So it has to be 1, 2, 3 as well. It will end up right here. What about this? Okay, this is quite far. 1, 2, 3, 4, 5, 6. So count 6. 1, 2, 3, 4, 5, 6. It will end up right here. Okay, what about this? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so you can see already the shape taking place. All you have to do is to just connect them, right? So connect them nicely. Alright, this is the easiest part to do once you have everything. Okay, so connect them, and can you see that this and this are actually facing each other across the y-axis? Okay, so we label the image, alright, which is reflected from the y-axis as A double prime. Alright guys, so that brings us to an end, right, to this lesson. What have we learned? Okay, basically, the first 2 types of transformations. Can you name me? It is translation. And the next one, reflection. Alright, so just bear in mind the properties when you translate or reflect an object.
So alright guys, that's all we have for you right here. In the next lesson, we'll be taking a look at the other two transformations, which is the rotation and the enlargement. Alright, so see you in the next lesson. Goodbye for now.